Hi guys. Today we're going to do lesson 10 for Eureka. We are going to, in this lesson, the Eureka teacher goes through reviewing rounding. Remember, if you need to use your number line still for rounding, please do so. You want to use that resource as long as you can until you can work out of having to use it and be able to do it mentally. She's also going to go through some real world problems that have to do with rounding. So putting it in a real world perspective. I will probably stop the video here and there to ask questions or explain something.
Miss Sloan, if you're in the
Sorry about that. To explain something or to do another practice problem if I feel like we need it. If not, we're going to just keep pushing through our lesson. It should not take very long today.
Hi friends, I'm Mrs. Gridney, and today we'll be rounding multi-digit numbers in real-world situations. Let's get started. Let's begin by just reviewing rounding. Remember, you can picture that vertical number line in your mind if it helps you. And remember to ask yourself those questions we learned in the previous lesson. Whisper read this number. 935,292. Pause the video and round this number to the nearest 100,000.
So use this time right now, pause it, and use your number line and round this number to the nearest 100,000.
$935,292 rounded to the nearest 100,000 is 900,000. We just rounded to the largest unit. What's the next largest unit we might round to? The next largest unit we might round to is 10,000s. Pause the video again and round 935,292 to the nearest 10,000 and then round to the nearest 1,000.
So pause your video and round using your number line if you need it to the nearest 10,000 and then to the nearest 1,000.
$935,292 rounded to the nearest 10,000 is 940,000, and rounded to the nearest 1,000 is 935,000. What changes about the number as we round to smaller and smaller units? You may have said that when we round to the largest unit, all of the smaller units have zeros. Rounding to the largest unit gives us the estimate that's the easiest to add, subtract, multiply, or divide with. As we round to smaller and smaller units, the estimates have less and less zeros. But also, as we round to smaller units, the estimates are closer to the actual value of the number. Now it's time to put that rounding into context and think about how we would use rounding in the real world. Imagine the White House. Do you know what the White House is? The White House is where the President of the United States lives and works, and it's a popular place for people to visit each year. Let's read this together. In the year 2012, there were 935,292 visitors to the White House. Wow, that's a lot of visitors. Now let's assume that each of the visitors will be given a White House map. Pause the video and use this information to predict how many White House maps would be needed in 2013. And explain how you made your estimate.
So this is an amazing question to help us think about rounding in a real world type situation. We're taking this number, the number of visitors that came to the White House, and we're trying to use that number to estimate about how many maps they're going to need for visitors in 2013. When I thought about this problem, I think that I would like to have as many maps as possible. So I would round to the highest place value here. However, if you are into maybe saving the planet and wanting to make sure we're not wasting paper, then you might want to round to a lower place value, like the thousands place. But I would hate to run out of maps if I had visitors who needed them. So I would round to the 100,000th place.
Maybe you rounded to the nearest 10,000 and predicted that they would need 940,000 White House maps in 2013. This would be rounding up, and maybe you thought that it would be better to have more maps than not enough maps. Or maybe you thought that maybe more people might visit the White House in 2013, so you rounded up to 940,000 because this was the only estimate that was greater than the actual number. Here's some more information. Let's read it together. In the year 2011, there were 998,250 visitors to the White House. How does this new information compare to the information that we already have?
So think about that. How does the information about how many visitors visited the White House in the year 2011 compare to the amount of visitors that visited the White House in 2012?
This new information tells us that there were more visitors to the White House in 2011 than in 2012. That means that the number of visitors decreased from 2011 to 2012.
My question for you is, if we used the number that we rounded to the 10,000th place, 940,000, if we made that many maps, but we had the number of visitors in 2011, would we have enough maps?
How might this new information change your estimate for the number of maps that would be needed in 2013?
So her question is, how are we using the fact that the number of visitors has decreased each year, or from the year 2011 to 2012, how can we use that to estimate our number for 2013? Do you think we're going to need more maps in 2013 or less maps in 2013 if the number of visitors is decreasing?
Maybe you're thinking that since the number of visitors to the White House decreased from 2011 to 2012, it might decrease again in 2013. So maybe we won't need as many maps after all. It might be better to predict that we would need 935,000 maps or even 900,000 maps in 2013. What does this tell us about how we can determine the best estimates in any given situation?
You know what? I made a mistake. I thought that if we rounded to the nearest 100,000, that we would end up with more maps, but that is not accurate. If we round to the nearest 100,000, we actually end up with less maps. So, do you see how rounding can be very confusing? And when we're estimating, it's very tricky to figure out what we should estimate to. We have 3 different answers here that we could estimate for the number of maps to help us predict the number of maps we're going to need in 2013. So let's rewind a little bit and consider her question one more time.
This tells us about how we can determine the best estimates in any given situation.
Okay, so we're thinking about how can we consider the best estimate in any situation? What is our information telling us?
This tells us that we can look for patterns or find data to help us make better estimates. There's no one right estimate in any given situation. Let's try another one. Let's read this statement together. 2,837 students attend Lincoln Elementary. How might you estimate the number of chairs that the school would need? Pause the video to make your estimate and explain your reasoning.
So you need to estimate how many chairs do you think that they are going to need at Lincoln Elementary? Think about what are you going to round to? What place do you think is the best place to round to get you an accurate estimate of how many chairs are needed at Lincoln Elementary?
Maybe you thought that we should round to the nearest 1,000 for an estimate of about 3,000 chairs, because that would give the school more than enough chairs.
That would give the school, I want you to think about how many more chairs does that actually give the school? How many more chairs would they have? Or how many extra chairs would they end up having? That's a lot of extra chairs. It's approximately 200 extra chairs.
And if we rounded to the nearest 100 for an estimate of 2,800 chairs, then some students wouldn't have a chair. That makes sense. Or maybe you thought we should round to the nearest 100 for an estimate of 2,800 chairs, because 3,000 chairs would give them almost 200 too many chairs. That would be too many extra chairs. And even though 2,800 chairs wouldn't be enough chairs for all students, it's almost enough. And so maybe you're thinking, well, there will be some students who are absent each day, so that should be enough chairs. Either way of estimating could work for the school. So what does this tell us about choosing the best unit to round to when we're estimating? This tells us that when we're trying to choose the unit to round to when we're estimating, we need to think about the situation and what is the most reasonable. I think we're ready for...
Before you start your practice problems or your must-do problems, I want you to make sure that when you are answering the practice questions, if it says explain, you really, really need to have a good explanation for why you rounded the way you rounded in your practical, real world situation problems. Because don't just give an answer, you really need to explain why. What is your reasoning behind your answer, and why did you choose that answer?
Our problem set. The must-do problems for the Lesson 10 problem set are on the screen. Set a timer or watch the clock for 10 minutes to work on these problems. If you finish the must-do problems within the 10 minutes and you still have time left, feel free to try any of the other problems on the problem set as well. Today, we rounded multi-digit numbers in real-world situations, and we thought about how our estimates make sense. Remember to check in with your teacher, and I'll see you next time for another Eureka Math lesson. Bye!
Remember, make sure you're explaining your answers in great detail so that we know exactly what your thinking was. Don't forget to explain your answers.